All right, section 12-3 is a type of graph called a box and whisker plot. This seems more complicated than it is, so let's get right into it. We'll talk first about what it is and then how you create it, and then maybe we'll analyze one. So a box and whisker plot is a graph or some type of display that divides the data into four parts. And when the data is divided into four parts, what that really means is that each part contains 25% of the data. Now the parts might be differently sized, but they're each going to have the same amount of data. And remember, we can have outliers and things like that. So the best way to think about this is, let's look at an example. So I've got these numbers in dark blue. These are the average monthly temperatures in degrees Fahrenheit from a city, Caribou, in Maine. Okay, and they go by month. So in January, the average monthly temperature is 9, February is 12, April is 38. You can see June, July, August, we're in the 60s, and then way back over here at 15 for December. Okay, so we have 12 pieces of data. And the first thing that we're going to do is, even though it doesn't say this in our number, okay, really, whenever we have data like this, we really just need to put it in ascending order. So what you see down here, right, is that I have reordered the data, not by month, but starting with the lowest value, right, so 9, all the way up to 66. And we're going to want to pay attention to those numbers, 9 and 66. So let's follow our 6-step process for the creation of a box and whisker plot. Okay, so step 1, find the least and the greatest values. We tend to call these the extremes, right? So find the lower extreme and the upper extreme, right? So there's the lower extreme, or the smallest value, the least value, and there's the upper extreme. And the other part of step 1 is to draw a number line and to appropriately label it so that we can fit all this stuff. So you can see I've got a number line down here, and I'm going to go ahead and label this 0, 10, 20, 30, 40. Now obviously I've put a little bit of thinking into this, but my number line really definitely had to go probably from 0 up to 70, and mine went all the way up to 80, okay, because I know that all my data points are 9 and 66 and everywhere in between. Okay, so I have now done step 1, which is to say I've found the smallest value, the biggest value, and I've drawn a number line, right? I've drawn a number line to cover the range. Step 2, find the median. That should be easy enough. There are 12 points, so 2, 3, 4, 5, 6, and 7, right, are my middle two values. So my median here is going to be an average of 38 and 43, so that's going to be 40.5. Okay, and I'm going to want to make sure that I remember that because I'm going to need to do something with that in a minute. Okay, then I've got to find the LQ, which is the lower quartile. Okay, now remember, there are there are 6 numbers over here, right? So this is a little bit more challenging, right? So I've got to take the average of 3 and 4. So the LQ in this case is going to be an average of 15 and 25, which is 20. And I want to do the same thing. I want to find the upper quartile. So I've got, again, over here, I've got 6 numbers, 43, 51, 54, 61, 63, 66. So my UQ is going to be an average of, it's going to be the number midway between 54 and 61, right? It's the median of the upper half, right, which is this midpoint in between 54 and 61, which is like averaging 54 and 61. There's 7 apart, so go 3.5 up from 54, and you get to 57.5. Okay, at this point, I want to mark all of my points, right? So we have found the median, we have found the lower quartile, we have found the upper quartile. I need to mark all my points, and I'm going to do it above the number line. So above the number line. Okay, so 40.5 is the median, so that's about there, right? 20 is the LQ, that is about there. 57.5 is the UQ, that's somewhere around there. And I also want to mark the smallest and the greatest value. So the greatest value is 66. It's about there, and then the smallest value is about 9, which is about there. Okay, so I have marked 5 points. I've marked the smallest, I've marked the LQ, I've marked the median, I've marked the upper quartile, and I've marked the upper extreme, or the largest value. And then finally, okay, step 6 says draw a box from the lower quartile to the upper quartile. So that's going to be from here all the way over to here. Okay, and usually I like to draw a line that represents the median. Okay, and whiskers to the extremes. So that would be from here over, right, to 66, and from here over to 9. That, my friends, is a box and whisker plot, and it shows you lots of information, right? It shows you when you come up, you know, okay, this must be the median. If I were reading this, this must be the upper quartile, this must be the lower quartile, this must be the highest value, the upper extreme, this must be the lowest value, the lower extreme. And also remember, this represents the middle 50% of the data, right? The middle 50% of the data divided, right, into 2 halves, right, by the median. So when I said at the start that the box and whisker plot divides the data into 4 parts, right, with apologies for drawing all over this, right, there's one part, okay, here is a second part, here's the third part, and here is the fourth part. Now, there are really no outliers in this data, so these parts all look about the same, but sometimes they're not like that. I can show you a quick example of that. So we'll just look at this one quickly, but here you see a box and whisker plot drawn for you. The title of the plot is The Weight of Asiatic Black Bears in Pounds. And you can quickly look at this and get a sense of the data, right? So the box goes from 225 to 250 pounds, right? And you can see that the middle 50% of the bears weigh between 225 and 250, right? Which is to say about half of the bears, right? About half, the middle half, weigh between 225 and 250. Okay, on the lower quartile, right, the lowest quarter is about 200 to 225, because you can see the lower extreme, right, the lower extreme is down to 200. It's pretty bunched up there, whereas the upper 25% goes all the way from 250 up to 400. So it's much more spread out. And you can see that our upper extreme, our heaviest black bear from Asia, is about 400 pounds. Right? So this just shows you a much longer tail, if you will, on a much longer whisker on the higher side. It also shows you the median, right? This line represents the median, which is clearly closer to 250 than it is to 225. If that matters, I don't know. But this gives you a very quick snapshot and pretty informative snapshot about what the weight of black bears look like just from this picture. And that's sort of the power of graphs. They allow you to interpret them and get a lot of information quickly, frankly, without doing a lot of reading, although you do need to do some pretty careful analysis. So those are box and whisker plots. And remember these steps from writing out the numbers in ascending order, right, to finding the highest and the lowest values, finding the median, finding the lower quartile, finding the upper quartile, marking all those points, drawing your box, drawing your whiskers. not a lot of new information here. Again, building on what you learned in 12-2 and just how do you display it in a sort of graphic way.